Cool, so I'm JD Schomburg with Online Resources. We just got our new Creaform HandySCAN Black Elite in today. So we're gonna go ahead and open it up, plug it in, and start scanning some stuff. So first off, we'll just take a look at the system itself. Looks very similar to the structure of the old HandySCAN, with a lot more design and a lot more functions that we're gonna go over later on. So same concept, we have all the cords with calibration plate below. And this is something that's really cool. This is now the calibration certificate showing the ISO 17025 certification with the VDI VDE 3624 Part 3 acceptance tests. So that's pretty cool. So we'll go ahead and set it up and put everything together. So now I'm just gonna hook up the power cords here. And then the data cords. So these are just USB cords with a wall plug. And one of the cool things that they've done is they've put a stress reliever on the cord. So if I put this into my Ethernet port and then plug it into the USB, that's going to keep the wear and tear down on the product and on the wires. So that's a cool fix that they've done. I like that kind of thinking in the future. And then we just plug it into the back of the scanner here. And we are up and running. There's power to the scanner. So I'm going to go ahead and open our software now. And I have a habit of putting it down on its side. That's a nice feature. It has both pads on the side or the bottom, so you can set it up or on the side. One of the other neat features that they've added that I saw here when I pulled out the cord was a wrist strap. So you can put that on there if you want. I'm pretty comfortable without it, so I'm gonna hold off. And go ahead and grab this calibration plate. I also like the upgrade in the calibration plate. A nice sturdy case instead of the wood case, so that's going to be a little more durable there. And then they've also put a coded target on there so that you know which reference plate is connected to the scanner. So if I go into my configure, that's what I like to do first. The scanner, in the calibration. We'll go ahead and start scanning. So if you notice, this is a blue light system. So the lasers are, instead of the red, we're gonna have the 11 blue light lasers. So that's the calibration process. Still very simple, quick, easy. I do like how they've now added the shape of the scanner into the calibration process. So it's not a bar system that you're trying to calibrate within. So they've done a good job just on the speed of up and running. You can see that within a couple minutes we're already plugged in and ready to go. So knowing the resolution capabilities, this scanner now has 9/10 of a thou accuracy. So we're looking at 25 microns, and then resolution 100 microns, so about 3.9 thou resolution. So it's a good evolution of the HandySCAN and a jump up to the next level. Resolution is where the scanner is going to kick butt. So I've really pulled out some things that would challenge most scanning systems. Dental, we have a small punch here with some EDM curves. And then we also have a small turbine blade. And then a small pin, so a military style pin. So we're gonna go ahead and start scanning these and show you what kind of data we get. The VX Element systems, it's a little different, but I really like the changes they've made. They've simplified the software, so I still get to set my resolution. We can do something to kind of change the isolated patches that might be out there in space. And then they've also allowed me to do some optimization choices in a easy none, low or high setting. So I'm going to go ahead and keep that to the off setting right now. And then this is my favorite feature that clicked the wrong button. My favorite feature right here is scanning positioning targets, and then it will automatically create, or not automatically, but it will quickly create a clipping plane. So I no longer have to worry about the data on the lower portion. This is really important as I'm scanning in the really high resolution. I don't want to pick up any of my plate because I'm going to get a lot of data that I don't want to process. So we'll go ahead and add that clipping plane, and I'm just going to tell it to, I want to actually select the targets myself. I like doing things by hand. This can be a little bit more automated, but like I said, I prefer just to have that tactile feel. So then once we've done that and I'm ready to go in and scan my surfaces, so we'll go ahead and start with maybe the dental application, and then we'll move on from there. So real quick, again, this is at 3.9 thousandths of an inch resolution. So extremely close here. And then we still have our same functions to zoom in and get that kind of nice handheld feel. So it is, I mean, as we expect, it'll take a little bit longer to fill in the data, mainly because of we're collecting 1.3 million points per second. So we're dealing with a lot of information here. Awesome feature that I really like right now that I'm seeing is there is no distance meter, but if you look at the laser lines on the part, red means I'm too close, green means I'm a good distance, and then blue means I'm too far away. So they've changed that distance meter from the left side of the screen and placed it right on the part itself. So now I know exactly what kind of data I'm getting on my part. That's a really cool feature there. They've done a good job with that. So we just keep on going. You can see the resolution is awesome on this. You know, this is previously an application that would be more of a structured white light system. That's more of your tripod mounted, and this thing is just knocking it out. So this is pretty impressive so far. So we'll just keep, what I like to say, spray painting with lasers. So if I'm just focusing on the teeth, which is the main goal here, I'll go ahead and pause that. They've also mentioned that they've increased their processing speed. So that's something I'm going to be interested to see. We press and hold the scanner button, that'll process our data, and it looks like, wow, it looks like that took under 10 seconds. So this is our STL mesh right now, and then I believe if we click finalize, that will then process any other features that we've done over to the side, which we haven't really done much, so it should go pretty quick. We just have a little bit of remove isolated patches, so it's looking at those and deleting all that data. So that's pretty cool. One thing I like to do is see that surface quality. That's going to be, I mean, that's awesome detail. Surface quality, I'm going to go ahead and take off some of that reduced noise and recalculate and see if we get any changes around here in the teeth. Wow, that really smoothed out the data without losing any of the resolution detail. So this is really cool system so far. So I've pitched underhand for the moment because I think this is probably going to be an easy color to scan. So let's go ahead and take it up a little notch and do one of these. So let's reset scan just like we would. Keep the targets. Great, so it's acting just as it is. And then we'll start scanning this one. Go ahead and zoom in a little bit. I might have to bump up my shutter speed a little bit. Let's see. Oh, might be. And again, I'm still at the 0.1 resolution. Might be a little overkill for this part, but I like to test it, see how this scanner really works. It's acting just as I would expect it to. Creaform does a great job of putting out a product that when you put it in your hands, it does exactly what they say. This is going to be a game changer in the quality control market. I mean, having this kind of resolution and accuracy in a handheld system, that flexibility to go on the floor. And we're still getting way down in there in the key side of, so I'm getting good clean data all the way in those gaps there. So this is pretty cool, guys, the speed of this kind of resolution. This is exciting. So we'll go ahead and process that, see how that goes. And then I'd really like to challenge it with this EDM part. So we'll go ahead and finalize that and see. So it's a little different. There are a lot of other features in here that I still haven't had a chance to play with. But something that we can actually, instead of using the full volume of the scanner, go down really small into the details. And I could probably go over that a little more. I'm actually going to do that. So let's see if it still allows us to go in and keep scanning. So I'm going to open up my scan session again. Cool. So it acts just as I would hope it should. And I think that I just needed a little less or a little more laser powers. Probably what they would want me to do is calibrate, or not calibrate, but configure the laser power to this part. I'm pretty comfortable just with the previous generation, so that's probably something I should have gone through that process a little better, but it's still working great here. So yeah, I was a little low on that laser power, so instead of being at a 0.35 laser power setting, I bumped it up to the 0.9, and it just was able to clean up and get a better surface on that. So let's go ahead and process that now. And you can see that it goes through a two-step process, so it immediately has an instant mesh that we can send over to whatever program. And then if we want to put any of these, remove isolated patches or change the resolution, it'll go through the secondary phase to calculate that. So they've done a good job of, if you don't need to do all those processes, just dump it immediately. So as you can see, still great resolution getting all those keys in there. So we'll go ahead and reset, and the last one here we will do is a very fine, I don't know if we can get in a close-up on that, very, very fine teeth in there at all different angles. So this is one of our test pieces that we use. Any new system that comes in, we like to make sure it can do this successfully. So we'll keep it at that high resolution and go right into it. And I am already seeing some really good detail on this, so that's and this is a hard piece because it has curvature in all different kinds of angles. So a standard system structured light tripod mounted system that you would usually expect to get this kind of resolution and could only do these kind of parts really struggles with getting in some of these, the back sides of these curves and spikes. So and I like this instant mesh. We're no longer, the way it was explained to me is we are no longer collecting the point cloud. We're actually collecting the STL mesh as we scan. So I can be confident that I'm collecting the data I need as I go around. So I know this is a little longer video than we usually post, but I think it's really awesome for everybody to see the speed of this kind of system. We scan 3 parts now in a high res setting, and it's probably a little overkill. I'll go around one more and get the back side of this block, and but like I said, I could see this as a game changer for the medical implant type of industries. It's going to be a really cool setting. So let's go ahead and process that one. And I'm going to try to see finalizing with just a few different features on and see what that does. See if that takes a little bit more time. So I really like to test the system right when I get it and see if I can push it to its limits. I mean, we're at about 8% of our RAM. Another nice feature of this is they're playing to the GPU as well as the RAM. So we're seeing really low, 8% of RAM, 6% of GPU. So it's really processing at a high speed. So as we go in, let me set my rotation center. Same, nice to see. I didn't even think about that, but that's habit, same settings as usual. We're gonna go in and look at those spikes there. So just that resolution capability is really cool. So I'll go ahead and end there, and that's my first opening of the HandySCAN Black Elite from Creoform. And right now, first impressions, it's really cool. So if you guys have any questions, let us know.